Hello everyone. We will start today's session shortly. Till some more participants join in, could you quickly confirm if I'm audible? You can type a yes in the chat box. Thanks Devashish for confirming. Just couple more minutes and we'll start today's session. Uh, Good evening, everyone, and welcome to today's webinar, which is Mastering Deep Learning, Building the Minds of Tomorrow's AI. So, we are thrilled to have you all join us as we explore the cutting edge technology which is shaping the future of artificial intelligence. Deep learning. So, in this session, we will uncover the fundamentals of deep learning, examine how these neural networks are designed and trained to emulate aspects of human cognition and demonstrate how this technology is driving advancements in areas such as computer vision or natural language understanding, robotics, and intelligent decision making. So, and to help us unpack this fascinating topic in greater detail, we are delighted to have with us our speaker for today, Rushikesh Meherwade. He is the founder of Vidvatta. He's also an accomplished data scientist with over a decade of experience in performance testing, application monitoring, and Java tuning. His expertise spans across NLP, which is natural language processing, machine learning, and mentoring tech professionals in both startups and global enterprises. He has worked closely with top edtech platforms and global organizations, bringing both technical depth and educational clarity to everything he teaches. So, his passion for teaching and hands on experience in building intelligent systems make him the perfect person to guide us through this session. And how you all can participate. This is going to be an interactive session, so please feel free to drop your questions in the chat box or else in the Q&A tab at any point. We are here to learn together, so no question is too big or too small. Ask as many questions as possible. So, without further ado, let me invite Rishikesh Meherwadi. Over to you, sir.
Hey, hi guys. Just give me a second. Hey, hi everyone. This is Rushikesh Meherwade. So today we are going to go through some interesting topics around the machine learning. The topic being mastering the deep learning, like how the deep learning being a core field from where many of the AI advancements that you see today are actually coming from. So we will be going to like how that actually makes the difference. So let me quickly share my screen for all of you. Okay, so just I need your quick help to know if you're able to see my screen, guys. Like, are you able to see the screen? You can just put it over the chat. That will be very helpful. Great, Ruby. Thanks, Devashish. Awesome. Good to know that, Ananya. Great, great. Thanks a lot. So, just to give a brief about myself, my name is Rishikesh Merwadi, and I have around 13 years of experience in the software industry field. Last few months back, I used to work as a vice president of data science in Motilal Oswal. Recently, I'm working on an AI company in education space and other related things. Okay, so in last work, we used to mostly lead. I used to lead a team around. The team used to work on the data science, AI-based problem statement in the financial domain. So my major experience has been in the financial domain. So across this 13 years which I have been, out of that, like initial 7, 8 years have been in the testing. Okay, initially I used to work in the performance testing, load testing, these things you may have heard about if you're coming from the QA testing background. So initial few years I used to work in this part, but then we used to deal with lot of data in the performance domain. So uh, in the data part, when we are doing the analysis, we got to know that this is like a very big field in itself. Around 2015, 16, I got to see that there's a field called as a big data engineering, there's a field called as a data science, AI, all the different things like that. But one major hurdle at that point was everyone used to say that, okay, data science, ML, all this field requires a maths as a background. And in the engineering space, I used to be from the diploma background. So diploma people are considered like not to have a good maths because you usually have a gap in a maths and that creates a challenge. So I used to always like procrastinate. I will learn. Every year I used to think through that. But then I made a decision that, okay, I'll go with some structured approach. So around 2017, with Great Learning, there was a course called as Business Analytics and Business Intelligence. So at that time, more of like classroom-based sessions was there, which was an hour. We used to go every month, weekends to learn about machine learning. And the machine learning was very new at that point. Like everyone was still trying to get up with that, but we had a good course from Great Learning around that point. So I was able to get through that and then was able to make some slower transitions. So transitions takes time, but was able to make a full transition at that point. So that was a great thing. But after that, we worked on machine learning, computer vision, ML ops, currently working on AI agents, LLM, Gen AI. All these are different type of things which are there in this field currently. Okay. To power all these fields, one of a technology or one of a methods which give a power to all the different aspects of AI that you see currently is a thing called as a deep learning. So deep learning made a huge amount of changes with respect to the all the AI applications. Whenever you say AI in the background, there are some deep learning based models which are running. Those are also called as a neural network based model. Okay, either a deep learning. The deep learning is one of a name given as a non-technical word, but internally it's a neural networks. Also, we call it the artificial neural networks. So those are what internally present. So let's go through the journey and see how all of it goes hand in hand. Before we start, few things to clear. This session, let's keep it very interactive. Okay, it's not like any question is good or bad, as the team already mentioned. Every question is no question is bad or good. You can answer any question. Don't think of others. You just think of yourself. You want to learn something. You have to make a best use of it by asking the question. So please be open to ask questions. Anytime you can stop and ask the question. Okay. In between, I will have a look at the chat and I'll be able to answer. But whenever you have a question in your mind, just go over the chat and put it. Don't think of anything. Okay. Great. So let's get started. Cool. So when we talk about deep learning, okay, as the name says, see, in the overall terms of the sequence of things, there is a machine learning which learns from the data. Inside that, we have a specialized field which is called as a deep learning. Deep learning tries to understand the things in a much deeper way. Okay, it tries to learn the things in a much deeper way. So when I say deeper, see, we as the humans, when we are looking at things, for us, those are very simple. Okay, simple means we are from the childhood, our brain is so interesting that a lot of things are happening in an autonomous way, and we don't uh, get to appreciate the beauty of it. Okay, because we are able to see things and make quick decisions. We are able to talk. We are able to listen. all of the things we as the humans can do so efficiently. But for machines, it's not easy. For machines, we have to train them from the scratch that, okay, learn this part, this part, this part. Now, to do that, let's just imagine that we want to allow a machine to understand the difference between a car and no car. See, to a kid, if you tell that, see, this is a car, you just tell the kid 2 to 3 times. That kid will be able to remember it in the third or fourth iteration. The kid will point its hand directly and say, that, see, this is a car. I have a small kid, and we have seen that, okay, how kids learn so fast. But with machines, it's not that simple. So what happens is, with deep learning, it's a way by which it tries to break down the problem statement into smaller parts. It tries to go to a granular level. From that granular, it tries to build in a more step-by-step way. So when we talk about car, the first layer, see, these are all pixels. When we are sending it to the machine, everything is a small pixel. Every pixel has a value. So it's a grid of pixels. So in the neural network structure, okay, this is like a neural network structure where these are neurons, okay, which tries to learn the information in a more in-depth way, step by step. So first layer is all about the pixels. In the next layer, this model tries to build on top of it. So from the pixels, it now tries to go for edges. It connects those pixels and says that, okay, see, this looks like a curved edge. This looks like a straight edge. This looks like something different. So this second layer will try to learn one step ahead from the pixel, the edges. The next layer will try to add on top of this edges. Okay, for example, it may say that, okay, this is a window screen. Okay, this is a window area. This is a tire area. This is a bonnet area. Okay, so this is a boot area. So it will try to get to a next stage where it is able to bifurcate this thing. Then again, once we go next, it will again try to add more abstraction. So that's why we call it a deep learning, because it is not just learning the problem statement, but it is trying to break it into smaller pieces so it can learn in a much efficient way. If you give the car image directly and ask the model that, okay, learn it, we have to give multiple examples. Okay, we have to give some thousands of examples, and from those examples, it learns the patterns. And to give it a pattern, we also have to give it what is car versus what is not car. So we give it 1,000 examples of car versus some more 1,000, 2,000 examples of non-car. So then machine tries to make a distinction that, okay, for the car, these kind of patterns are more visible, and for non-car, this kind of patterns are not present. It tries to add a probability. So there is also probability that goes into it, statistics, probability, and all these operations. This image that you see, image is represented as a matrix. Okay, so it's actually a matrix form where every pixel is a value in the matrix. You also have RGB layers that also brings like whole, we call it a tensor. Okay, when we go beyond the matrix and add some more dimensions, we call it a tensor. So the tensor as a one more layer gets added. So there is a linear algebra. In terms of the learning of the pattern, there is a probability that, okay, if this pattern comes in this form, this much way, for example, out of those 2,000 images, when we say that, okay, this pattern is coming high probability in cars versus the non-car. So then it learns that, okay, whenever this pattern in the future it is going to come, I will give this much of a probability that this is a car. This kind of thing we as the humans are not adding. Okay, we as the humans are not adding. These are getting learned as part of a whole learning process. Okay, the whole learning process, we just try to give the example. We just try to give the examples and we work on setting this models. Once we set this models take care of learning these patterns. Okay, we also have the deep learning. There is an additional benefit. This patterns which I told you, right, that is also called as a features. Okay, we call it like features within the data. So deep learning has the capability that it can automatically extract this patterns by itself. Some patterns could be more as the way we humans can interpret. Some could be which we as a humans may not even be able to interpret, but machines is able to use it in a much more better way. Okay. And then finally, like we have this classification based thing, which actually classifies this into the different distinctions. This kind of a learning is not just with images, but this can be applied to any type of problem statements. Be it images, NLP, audio, any kind of a data we can pass in, and neural networks can learn some complex patterns from the data. Now, in terms of the applications, as I said, like it can be used for any kind of uh, data. So with respect to that, when we go further, applications open up in different type of areas. So it can be used in the cybersecurity, autonomous vehicles. You see that lot of data. Autonomous vehicles try to gather lot of data as the information. It could be from the sensor, it could be from the camera, it could be from the internet. So all of that data, these machines have to make sense of, identify the patterns, and then take some decisions. Social media analytics in terms of Twitter or LinkedIn or any kind of social media, lot of data is coming again, which could be structured, which could be unstructured. For example, Meta goes through a lot of video and image analytics, where deep learning plays a very important role. Healthcare, medical, here also understanding the reports, diagnostics data, making sense in terms of the outcome, understanding the health report, or even the regularly tracked data, medical devices understanding, their health tracking. Lot of different use cases also comes in this field. Computer vision, NLP, these are like domains which are applicable in this different field. Okay, like in this field, these are more of domains, and these are more of tools which are used in those domains. Computer vision can be used across, like the image thing that we discussed. NLP, speech and audio, can also be used in different applications. Then talking about data science. Data science is like a process. It's a whole process of building the database application. Okay, be it machine learning, deep learning, adding the data related aspects of data engineering. All of it will become part of it. Okay. So, any questions till now? Yeah, yes, please. Like anytime you feel like you have a question, don't hesitate to ask the question. Okay, great. So now talking about how this deep learning model actually works. Okay, so the first step, as I told you, there is an input layer, there are hidden layers, and there are output layers. Okay, so output layer is where we try to get the final result. Input is where this input is coming. The input could be the textual data, the image-based data, the audio-based data. It could be a lot of different things. This hidden layers is where actual pattern learning happens. Okay? So within this hidden layer, this data which is coming down, this neuron, these are like neurons, and these are like neuron layers. All of this is built on, like, when the scientists started with this kind of things have been there from a long time. Okay, like deep learning has been there from a long time. Approaches around how do we build the deep learning based models, this has been there from a very good time. Can someone tell me like why this thing got more popular? Anybody knows? Algorithms have been there from a good time. But suddenly, why there was a big shift? Why those got like a good leverage and started to make a big impact? Why those things suddenly happened? Any idea? Can someone tell me? In the chat, you can answer. That will wait for 1 minute. So the question is, this algorithms have been there from a good time, but why? Like around 2012, 2010, 2010, this algorithm started taking a good shift. Okay. So why suddenly this algorithm took a edge? Hi, Ajit. Yeah, anyone who would like to add? Okay. Yes, Dasari. We were saying till 2010, there is no much data. Okay, that's very good. Dasari, yes. So one was data, but there's also one more thing, right? So one is data, that's good. And there's also one more aspect to it. Yes, Devashi, that's very right. Increasing the processing power. So these two things actually made a very big difference. So algorithms were there from a good time. People were not able to apply it. So around 2008, 2005, around 8-ish time, there is a trend of big data. Every company started to leverage the big data. So they started, okay, let's collect the data and we will do some analytics. We will do dashboarding, we will do MIS, we will do analytics. So a lot of things started and people like how do big data, all of this got very popular. People started to do the saving of the data. So till that point, not many were interested in saving the data. All of only like very important data was getting stored, but not much. But after that, all small, big data, everything people started to store because the disk cost started getting lower. So disk cost was not a big thing. So people started to leverage the disk cost by storing a good amount of data. So when the data started coming, people had a question, okay, now what should we do? Now we are able to get some insight, but now what is the next step? What should we do now next thing? So compute processors also started coming. Data is also available. So people from the deep learning research, they started to leverage this and then started, okay, let's work on applying these algorithms and see what kind of impact we can get. And then around 2010, 12, lot of things got like jumped. Then the boom started around the AI. So the boom of AI started with the implementation of deep learning because deep learning models were very good in terms of processing text and images. Okay. And before to that, processing text and images was very tricky. Not many were able to process the text and images very efficiently, but deep learning started to make a lot of changes. Deep learning also allowed us to store the learnings. We can store this learnings from one learning. And this learning from one side, we can also leverage in the other process. That's also called as a transfer learning. Because see, we also as the humans don't learn everything from the scratch. We have evolved over so many years, right? We have evolved over so many years, and the brain that we have is basically the learning from all the different generations. So this learning, like when we start as a kid, we don't have to learn a lot of things for so many years. Many things are just inherently available to us because we already have got a lot of learning in the brain. The brain has evolved, and we are trying to add on top of it. Same thing, deep learning also started to give us where learning from one project, you can save it. And then again, when we start a new project, some of those learnings can be reutilized. For example, as I said in this neural networks, one part is the second part is learning like the edges. Third part is like learning some more complex stuff on top of edges. So if you think of it, those things started to take a edge. So you can store some of these layers, and when you take it to a different project, this edges and some part of those learning on top of the edges would remain similar in other projects also. We'll be adding on top of it. That's what the transfer learning, where people then started to make a bigger progress. For some part of learning is now available. I can make a jump, and then on top of that jump, I can again build things which are on the top. I don't have to start fully from the scratch. So that, like these three, four things, made the whole deep learning field go a very big in this term because then people started to create some big models and they started saving it and giving it to the community. Community started to make a good use out of it. Community used that and again started building bigger things on top of it. Same way now also you will see that these GPT based models are also a very big deep learning based models. So um, you may hear this term called as 3B, 17B, 8B, 60B, 70B. So with all of these LLM models, okay, for example, Llama 7B, Llama 3B, there are this B which are billions. These are these parameters. Anybody knows here what are those parameters? Like what do we mean by the 7B, 3B, 70B? What does it actually mean? Who can tell me? So you see that lot of this LLM model, we've already heard about the LLM models. right? Like Mixtral, ChatGPT. So ChatGPT is everyone using. There are also open source models like Llama, Mixtral, Phi, Quen. There are just many different models. But everyone comes up with this parameter 7B, 1B, 3B. So that's very good. You said input parameters. But what does those input parameters? What does those parameters basically mean? Okay, so what you see here, the hidden neurons, right? These neurons which are learning the patterns. Okay, these neurons which are learning the patterns. These are the parameters, and like this, there are 7 billion. So when you see here about this 7 billion 7B, these are called as a parameter. Okay, these are the parameters which are learned, and when we say 7 billion parameters, the neural network has 7 billion neurons. Okay, so when we say 7 billion, those neurons will have a like those models will have a 7 billion neurons like this. So this is what this neuron. So internally, these are neural network models, and being a neural network model, they work on these parameters. Parameters are nothing but some kind of a learning. Some kind of a learning is happening between this individual one parameters. I'll say like we're learning about edges, pixel, blocks. It tries to learn some complex patterns out of the data. The more bigger we have it, lot of different patterns we can encompass within that. So same thing happens with the LLM models also. LLM models are nothing but a large models, which are some, there are different types of models. There are types called as RNN, LSTM, transformers. So these are the transformer view models. Can someone tell me what is the full form of GPT? So, Virati, as you say, dimensions, layers of neural network. It's not just layers. It's the overall individual neurons which are present there, Virati. Yeah. So, Sudhakar, it's not just vector dimension, but it is the overall individual parameters. Okay. So, when we say dimensions, more of it will be one dimension. Okay. When we say vector dimension, but it's the whole. That's the beauty of it. Okay. So, who can tell me the full form of GPT? Can somebody tell me? Great, Dasari. Great. If it's a generative pre-trained transformer, as the name itself says, good Devashish. Great, great. So, as the name itself says, it's a generative, which is like a form of a generation. It's a model which output is more of generative. Its goal is to generate things. The second word says that it's a pre-trained. I talked about the learning, the transferring of the learning. That okay, we can train it in one place and then can extend it again with a new learning. So that's the pre-trained part. So even the GPTs can be pre-trained. They are already pre-trained. They can extend if you want to. That's how the whole community is growing. What's happening is it's not just about one model, but when one company open sources it, other companies try to build on top of it and make it bigger. That's how the whole field is growing step by step, where one person builds it, makes it open source, others start building on top of it, and this way the whole community grows. GPT recently, OpenAI, recently just like I think within 1 week, they finally released like all their models were closed to source, even if their name being Open AI, all their models were closed. Means not others can actually access the neural network. Everyone was able to access only through the API. You can't access the actual neurons which are present internally. But recently, they open sourced some models which the whole community can utilize. Okay, so recently that happened. So everyone can keep building on top of it. So the overall goal here is the input layer, output layer, and there will be in between hidden layers, which are in terms of core learning, which is going to happen within the hidden layer. They will learn some simple complex patterns to represent the input to the output. Okay, when we say input to the output, basically when we're saying this is the car pixels and this is the car. So from input to output. Okay, this pixels being presented is represented as a car. That kind of a learning is represented by this hidden layer. Okay, so let's move ahead. Let me see the question. So Virat is asking, when is the next batch? Okay, so Virat, I think our team will share the details to you. Okay, great. So now, if we talk about the difference between the machine learning and the deep learning, machine learning used to be more of a tabular and structured data model. Okay, so for example, when you fetch, for example, when we say, is the person going to default a credit card or not? Okay, so you want to make a prediction that okay, this person is going to be a defaulter. So to do that, we have to identify certain parameters. Okay, for example, what is the civil score, what is his age, what is his salary, where he lives, what kind of loan he's expecting. We try to look through the whole history. Okay, this people in the past, this kind of behavior, they paid the loan, and this kind of behavior, they didn't pay the loan. This was a more structured data. So when we pass it to the machine learning learns the patterns between the input data versus the output data. Okay, like expected the user's behavior versus what we expect, it tries to learn that behavior. And then we get the model. So this was still simple. This is we call as a structured data. But when we go to textual data, image-based data, audio-based data, these are not structured, right? Because images are represented as a pixels and they have a spatial nature. Text has a very different structure. Text has a timeline associated with it. For example, now if someone asks that, okay, what session is running? Okay, if somebody asks a question, what session is running? We are talking about mastering the deep learning. So this has a time relationship. And when we started the session, then only we talked about this topic or this word. After that, we didn't discuss about that. So representing this kind of thing requires a time-based relationship. So those kind of things we do with the text. So uh, the text, images, audio, all these were very tough problems. But with deep learning, we were able to achieve that. So that's a core difference, I would say. Complex patterns, we started to leverage with more of a deep learning based algorithms. Some simple statistical and probabilistic patterns, we stayed with the machine learning. Even now, when we have a simple problems, we directly go with machine learning because machine learning works much faster. And if the data is smooth, it can give you much better results. Deep learning requires some effort, some good data, good efforts, good algorithm work. All of that would be required when we're going with the deep learning. So we make a decision that okay, what type of data is it, what complexity is it, and then based on that we make a pick between machine learning and deep learning. So can work with smaller data sets, can work with large complex data sets. Better suited for simple tasks. This is more suited for more complex processing. Takes less time to train. Train is nothing but like we make it understand the patterns between input and output. Takes more time to train the model. Models are built using important features. Features are patterns. With machine learning, we have to do some extra work. We have to do some extra work in terms of identifying what kind of patterns are present in the data. Then only we will feed it with the machine learning. With deep learning, uh, we don't have to specifically hardcore define what are we expecting as a pattern. It will do that. Because see, with NLP, computer vision, identifying exactly what is the pattern is difficult. But deep learning is able to cater to that. Less complex and easier to interpret the results. It's more of a called as a black box. Okay, you might hear the term called as a black box versus white box. Black box, we only see the input and output. We don't know how it is making that decision. Okay, how it is making that decision because that decision could be complex internally. It could be mathematical, it could be rule based, it could be some form of a decision structure, or it could be some complex derivation for calculus integration. It could be anything. But we can't make a straightforward distinction that okay, this is the input, this is the output, this is what is happening. That is tough when we talk about black box. White box, the rules are very clear. We understand what the model is doing, why it is making certain decision. For example, if we just talk about the credit card defaulter, the model may have learned that okay, if the age is greater than this, CIBIL is greater than this, and salary is greater than this, then this person will pay the loan. Some simple rules. but it is identifying by itself. That's the white box. Okay, so and machine learning can work good on CPUs. You don't need a lot of complex hardware, but deep learning will require a good GPUs if you want to get a performant model. Otherwise, they will run slow. Deep learning models don't work good on the CPU, whereas deep learning models can work on the GPUs very well. GPUs have some kind of a structure which allows it to process the mathematical data or a matrix-based data much better way. So that's where this can do that activity very well. Okay, so ML cannot handle large data. So the three ML can handle large data, but the only thing is it can handle some limited complexity. Okay, it can handle large data, but it can handle only the limited type of complexity. If the complexity is higher, then we have to go to the deep learning. But if the complexity is okay, so just to represent the complexity, the data we may require based on the complexity again. If if the patterns are simple, we will require lesser data. But if the patterns are not that easy, we will in ML also we will require a large data. Okay. So in terms of application, if we speak, there are a lot of different applications that we even mentioned in the start. So first is like if we talk, there is a computer vision. So with respect to computer vision, deep learning models can understand and interpret the visual data very well. So you may have seen a lot of different applications around object detection. So object detection is just to identify that there is some kind of object is present in this image or not, or even just identify, cut it. You will get a block which says that okay, this is where your person is. If you want to let's say identify a person in the image, so this person will be cut and identified. Let's say you just want to identify the face, so this can just identify the cut of a face. Then the recognition, identifying that okay, this is a person. One is to see that okay, there is an object present. Second is to recognize that okay, this object is a human. You may have seen lots of different applications around it. Those are all built mostly in the deep learning based application. Okay. So second is the image classification. Classification is more of given an image, you just provide a class that okay, whether this is animal, this is a plant, this is a building, this is a person, this is the inside, this is a vehicle. So just based on the given image, you try to identify the class. You don't want to get inside the image. You just want to identify that okay, this contains this type of information or not. That's the image classification. Then the segmentation is a more complex application part of it. So with this, what happens is you actually segment. Segment means you actually try to create a very accurate cutout. Okay, you try to do a cutout like this from the image. Okay, the segmentation try to do a very accurate cutout from the image so that you can extract that whole object as it is. With detection, it just detects that okay, this is where this object is present. Whereas with segmentation, it tries to just cut and provide you that exact object. Then the NLP. This is something I think everyone is using as an application in the current era. Majority are using. So, for example, ChatGPT in itself is an NLP, so textual data processing, but it's a multimodal. We call it multimodal, where it can handle also multiple types of data. Right now, these models can also understand images and text together, but they all started as a mainly textual application with NLP. The ChatGPT is like a very complex model, but even before that, there are a lot of simple models for processing the textual data. There are simple use cases where using those, we can work much faster with the text. Automatic text generation is one of a process with the transformer models, which we have seen. But we can also build a custom small model. Right now, these models are huge. Okay, these models are huge, but if you want to build your own custom generation models, we can fine tune this transformer models by giving it our own data and make them learn something very specific, domain specific or some specific aspects. Then the language translation, translating from one language to another, is again NLP based application. Sentiment analysis, identifying what the person is talking about. What is the emotion? For example, is he happy? Is he sad? is he angry, or so this identifying based on the words, combination of words, the emotions of a person. So that becomes very useful in different applications like customer service or majorly in the customer service, but even social media analytics, customer service. These kind of use cases, we can understand or gauge what the users are talking about. Let's say in the stock market or even the crypto market. So based on what people are speaking, based on that the markets actually change. So it's all about understanding the sentiment of the text and making a decision. Speech recognition. Again, this is more on the audio, but what I'm speaking right now, you'll see that Zoom will be able to transcribe it very well. Even when you can chat with ChatGPT very well, you will be able to talk with it like a human because it is able to understand that text, recognize your audio and convert it to text, and then make a and this, like again, what happens is we call it speech to text. Speech to text, you'll have a text and a lot of analytics can work on top of it. Once you have it, the analysis output ready, you again have a text to speech. Okay, so TTS is it's also called as a TTS or text to speech, and then you provide the answer. So pipeline wise, you can have speech to text, do some processing, and then again text to speech. Reinforcement learning is one of other area which is very popular. For example, the game playing, robotics, control system. So this thing is currently being very popular in terms of trying to restrain the LLM models to follow the instructions. Okay, reinforcement learning is more of you try to provide a reward and penalty based system. Okay, reward and penalty based system and tell the model that okay, if you do this, you will get a reward. Okay, if you do bad, if you do this, you will get a penalty. A model that tries to understand, okay, what I do, I'll get a more reward, and what I do, I'll get a penalty. And it tries to maximize that reward. It will only do actions where it is able to see that its reward is increasing. So this kind of things are being used in robotics to teach the robots how to behave, how to act. That okay, if you do this, you will be rewarded. If you do that, if you throw the thing, to catch the object right, you will be rewarded. If you're not able to catch the object right, you will have a penalty. And this model will try to optimize. It's again deep learning models which are running in the background. So when it is picking, this models will learn this behavior and provide the reward and penalty. This is also being used in LLMs, and it's called as a reinforcement learning human feedback. So this thing, uh, when this like in ChatGPT, you will see that these models are able to understand you well, are able to talk to you in a very nice way, and able to respond to you in a nice way. But initially, these models are just text generators. Okay, so original GPT, rather than the chat GPT, to only talk about GPT, those are just a text generation models. But when you add the reinforcement learning layer and you try to provide a penalty versus reward for the good thing and bad thing. For example, if it tries to abuse you, so there is a penalty associated with that. So if it abuses, this model will be trained reinforcement learning, which will say that okay, no, this is a bad thing. So then it will try to refine itself, saying that okay, no, I should now behave nicely. So if I behave nicely, I'll get a more positive reward. So like this, in terms of gender bias, racial bias, or abusive nature, if even if the user tries to get it abusive, these models will not because they are fine-tuned with reinforcement learning for a good reward to behave in a nice way. Okay, so that is one of our use case in this situation. Then the advantages, if we talk about, it has a high accuracy, the performance-wise, deep learning. If you feed it a good amount of data, right architecture of deep learning model, we can extract a good performance out of it. Automated feature engineering, as I said, it can learn patterns by itself to some level. Scalability, this can be scaled to multiple clusters, multiple hardware. You can have like hundreds of GPUs running, and you can train. So ChatGPT and all are trained on a not just one machine. They use a combination of machines to train single model and also to host it. Even the running happens from distributed across this neurons. They are distributed across multiple machines. So that scalability is available with deep learning. Then the flexibility, they can be applied to different type of tasks as we discussed. It's very flexible in terms of what kind of problems we want to solve. And it can, like if you have a good data, we understand how this model works, we can transform that data to work with deep learning for different problem statements. Other benefit is continuous improvement. Okay, as you see, ChatGPT keeps coming up with a new set of updates on a regular basis. So there is a continuous updation that is happening to this model, either like same model or they try to enhance the structure of the model, like they add more neurons, layers around the existing model and try to make it learn in a better way. Okay? So you don't have to again like when you have a new problem statement, you don't have to start fully from the scratch. You can use that, keep improving over the time. Okay, so with that, if we talk about Great Learning, so there is a program, so Great Learning being the top edtech for both professional and higher education, they provide the best completion rates in terms of and also the career transitions. If we talk about their program in the PGP Artificial Intelligence Machine Learning, it's ranked number 4 in the US for business analytics, and also it provides flexible structure and also 12 months overall like 1 year of program where you will be going from scratch to the advanced concepts. Certificate by Great Lakes and the UT Austin, number 1 ranked program for many consecutive years, machine learning, and also has a peer-to-peer learning. Okay, you will be interacting or you will be getting a learning from very good industry experts. Okay, and then curriculum also has some prep work, so you can get started with Python, GenAI, all of this beforehand. Okay, these are like transition examples. So that's it for today. I'll be open for questions and the team will be sharing feedback surveys. If you want to get more details about the program, you can fill the form and the team will be able to get back to you. You also have the numbers and email here, to which also you can apply and you will get a response from the team to ask any kind of questions you have around the program. But now I'll be open to answer any questions you have around the content that we have gone through today. Okay, so please be open to ask anything you want, not just the content, but you can ask any type of question you have in your mind. Yeah, Devashi. See, I think Grok is built with a very different structure. Uh, Grok, they have kept it like that to some level. Yeah, but yes, like that layer can be added to make it better. But the creators have thought that okay, we will not and keep it open. So that's why. But some level of fine tweaking with the reinforcement will still happen. Otherwise, that model will be responding to very randomly. So let me see some questions from here. So what level of mathematics is required as per prerequisites? Okay, so see in terms of mathematics, if we talk about prerequisite is not required to some level, all of that will be covered within the sessions. Okay, but majorly the concepts which are required are statistics, probability, linear algebra to basic level, and some form of derivatives and the partial derivatives. These are some core mathematical foundations which are required. But during the program, all of those are also exposed, some being prerequisite and some being pre-work and some being in the live sessions. Okay, so what is the scope of AI and ML for medical graduates? Okay, see, now AI and ML as a field is trying to grow. So for you, if you talk about medical graduates should focus more on the use case part of it. There are many tools which are there, like ChatGPT and are just a few set of tools, but there are more specific, uh, domain specific tools which are available. You should explore them and try to utilize that if you're talking about medical tools. For you, it may not require to go through the full program, but some AI leadership program or AI for everybody program where you get to know the whole what is AI, what kind of components are there. So that kind of program will help a lot if you are coming from the medical field. Okay, so because this will be more of a technical program. Okay, if you want to get hands down deep, you want roles in the data science AI field, or you want to interact with people who are going to be, like, you will be interacting a lot with people who are from the field of AI, ML, data science teams. So there you want to be good, because otherwise the communication gaps will come. So one is you are going to be technically involved, or second is you are going to be involved a lot with the technical team. These two things can help you. Like, this program will help you. Okay, since I'm from legal background, I feel it too technical how this course will be useful for legal profession. So I think you got the answer which I discussed right now. Similar to what I mentioned for medical, it will be applicable to the legal. Yep. So Sangeeta, you can share the details with the team, and you will get more details about that. Algorithm is best for CNN based projects. So this is CNN itself is algorithm, right? Like CNN itself is a deep learning based algorithm, which is called as a convolutional neural network that tries to learn more of either a 2D, 3D, 1D dimension based data. So CNN itself is a algorithm. Any examples of using AI in telecom industry? So see, some of the use cases which I have seen is one is like a churn prediction. That is one of a well-known use case for telecom. But then I've also seen people talking about like packets analysis, uh, and also nowadays Gen AI is also being used in lot of analysis around the data, how the customers are connecting, where they are connecting. So a lot of analysis and prediction happens in the telecom industry also using the AI/ML. Okay, recently I've been talking to some telecom people who were trying to utilize the GenAI use cases in their industry, more of like understanding the packet structure. So this kind of data, I am not very good with that domain, but some people are working very good in the specific space. Okay, I hope Amit, I'm helpful on that part. So Sudhakar asked, what are typical job openings in India other than GenAI or agentic AI roles? I'm looking how this course on ML and deep learning are asked in GD exclusively. So see, currently ML and the agentic AI both are going together. Agentic AI is only few, like, many companies are exploring the agentic AI, but there are few specialized companies which still focus on ML. Okay, agentic AI is becoming very open now. Most of the companies are trying to go to agentic AI because many problems which were not solvable till now, through agentic AI it is solvable. So companies are focusing on that angle. But when you want to build a predictive application, okay, you want to build a predictive model that can use the data from the history, learn some, create some learnings out of it, and then utilize it for a future. For example, customer analytics, you want to make a prediction for the customer, whether this customer is going to buy your product or not, doing a recommendations, doing a personalization. So many of these things, ML is still widely being used. Okay, even in medical applications, finance applications, in stock market predictions. Okay, all of these cases, ML is being widely used. Okay, what causes hallucinations in LLM after such advancements in deep learning? What are the key challenges that still remain? See, hallucinations are there because, see, we humans are also not very complete, right? All the data we are feeding to the machine, which humans have created. Okay, and we as the humans are also not fully right. We are also as a human 95% accurate, 96% based on the different topics. So when we are feeding the training data to this machine, this wrong form of data is also getting fed. So because of this wrong form of data also getting fed, some learning this models will do will also be inaccurate. Because of that, there will always be a small percentage of hallucination which will be present as part of this model. But there are many different strategies which have come up, like RAG and memory and all of these things, through which we are able to control the hallucination. Still, a very small percent we expect, but to a good extent, we are able to control it now. The models have become much more better as compared to the earlier time. Now, the hallucinations is not something that everyone talks to a good extent. 2 years back or 1.5 year back, everyone used to talk about hallucination, but now it's not the thing. Not much of hallucinations. It's there, but reduced by a good extent. Okay, and there are strategies to work on top of it. Can you guide us regarding such AI programs for exclusive medical graduates? See, I would suggest you share your details with the feedback form. If there are such programs, the team like with Great Learning, the team will get back to you. Okay. So will there be projects and can you do some examples? Yes, Devashi, like there will be many different projects from a different angles, from a different domains. Okay. So you will be able to go through multiple different projects during the whole session. What about if someone having a rich experience want to do a career transition? So Ankur, it's see every company is now looking for the advancement that people should do, right? Like uh, current expectation from the whole industry is people should be able to upskill and transition into the new projects which can give more benefits. So even if you have a rich experience, now the market is expecting that you should be able to upskill to the new current fields and able to showcase that you can work on this new problem statement. So learning through this or even doing a career transition will be a added advantage. These are like tools. Okay, it's not like something fully different. These are an addition of tools which you're adding in your portfolio. Okay, so that you can say that okay now like you are being from the Java, .NET, Python, any type of field. But when you say okay, I have learned AI, you can apply it in any field, any applications. So that's a core benefit. What is the expected weekly time commitment for this program, including live classes? So around weekly, I would say 5 to 8 hours, based on again the complexity of the week which you are in. So around 5 to 8 hours as a weekly expectation would be there. ML AI is now deep into medical devices, specific patient output data management, regulatory scope of documentation. So, Vijay, like, thanks a lot for giving the examples. So yes, every field, I don't think like there is any field right now which is not being touched by ML. Okay, any domain, every domain, there are data. The data is at the core for any domain to work. Okay, and where there is data, there is ML and AI both. Which of the subfield deep learning will become more widespread and provide more job opportunities 5 years from now? Spend a year to learn and 2 years to practice in real life, and then they become outdated in the job market. Okay, so see, if I have to tell you about this, now these things are not fully outdated in terms of the technological things, right? ML being there from the 7, 8 years is still active. Java being there from so many years, .NET being there from so many years, it is still active. If you're not good in the core skills, you won't be able to implement good production grade applications, right? So whatever technologies have been there till now, they have sped up the whole process. Okay, they have sped up, but it doesn't mean that the human in the loop can go away. Human will still be there and all those fields are still active. The core foundational knowledge is still very important. Okay, so it's not going to go away, even if you learn for 2 or 3 years. The things which I have learned 6, 7 years back are still applicable, still being used by many industry projects. So I would not say that it will be outdated. See, some is a hype market and some is a real market. In the link in the social media, you will see some part of it being hype, but some part as the industry use cases are still there. So every technology will have a hype cycle. And after that, it will come down, but it will not be zero. It will always be usable. Uh, Sorry to say that. Can you pardon, please? It's clear. So, Sushma, I think the team you will fill the form, right? The team will get back to you. They'll connect for you with the for more details. Okay, I think guys, it was a very great and interactive session. Thanks a lot for your great questions and being so active. It always uh, helps, like it always like feels good to interact with you all. Yeah, please go on with the questions if you have, guys. Take any questions. I think somebody raised the hand. So if you have a question, please go on. Okay, I think the questions are cleared. Yeah, I think see, some have raised hands, but please ask the questions over the chat. Based on that, I'll be able to answer. Uh, so if there are questions over the chat, then only I'll be able to answer, guys. So please go ahead and put your questions. Are there any protection creating LLMs from scratch? So not fully from scratch, but transformer models will be able to build from scratch transformer models. We'll be able to understand transformer models. We'll be building projects on top of the transformer models. So this is going to be there, Sarga. So the core transformer model, which is being used in this, we will be able to go through those. Yeah. Okay. Thanks a lot, everyone. I think good to answer your questions. If you have any questions, please fill the form and team will be able to get back to you to resolve any questions that you have. Okay. Thank you very much. Please take care.